Right, our recording is in progress, and we are getting started with our lesson once more, and we are right back. Okay, we are right back. Right. So looking at question 4, we're going to start by looking at question 4.1. We look at this question, but we need to look at it again for the recording to be a continuous recording from the beginning to the end of the lesson. It's 10:48 a.m. I'm expecting, therefore, that we must discuss up to at least 11:48 a.m. You're gonna advise me time-wise, but yeah, that's what I'm planning. Right. So we just showed at the beginning that the P was 4 and Q minus 3. Let's just show that again. But we're given two lines, and these are the axis of symmetry of the function that. So, right. So these are axis of symmetry. The axis of symmetry, they actually intersect. So we're interested in the point of intersection, right? We're interested in the point of intersection. Right. So being interested in the point of intersection, what does it mean? Well, it means that x plus 1 is actually equal to minus x minus 7. These are the two equations of the lines. We're equating them to each other because they are axes of symmetry, or we call them lines of symmetry. We transpose the minus x to the other side, making it positive so that we have twice x. And then we have minus 7 and minus 1. So, which means 2x is minus 8. You divide minus 8 by 2, and it gives exactly a minus 4 there. Okay, so with the minus 4 obtained, what does it mean? It actually has implications. It actually means, therefore, we got the x value of the point of intersection of the axis of symmetry or lines of symmetry. Now, y equals x plus 1, and our x is minus 4 plus 1, and minus 4 plus 1 is minus 3. And therefore, right now at this point, we actually proceed to find the, to write down the equation. So in other words, the equation itself is written just like that one. So it is written as minus 2 all divided by x plus p, but q is added to it. So the continuation is as follows. So we have the function f, and this can be written as negative 2 divided by, okay, so we have x, but obviously it's a plus 4. It's a plus 4. You take the positive, the opposite of the number there. And then here you have the y, which is exactly negative 3 straight away. So what are the implications of these? So the implications are twofold. Namely, we have that our P equals and our Q equals, because they said show that P equals this and Q equals that. So we have that P is negative, is actually exactly positive 4. Is exactly positive 4. And we have that our Q is the Y value, and it is exactly a negative 3 there. So we have shown and we have answered the question for 4 marks. Okay, we did this earlier, but yeah, it's just to recap that, because the recording must not be interrupted quite, because if we shut down the system, then the recording starts afresh from the new time of connection. But yeah, if you just get disconnected, let me know. Then we're gonna reconnect you again, right? Because I'll have to accept you, because normally I admit a person uses the link. Anyone who uses the link can be admitted to the discussion, right? The x-intercept. Calculate the x-intercept in 4.2. How do we find the x-intercept? Right, to find x-intercept, you let y be equal to 0. If y is equal to 0, then what you have is the following. So we want to find the x-intercept of f. So you let y be 0, which means that we remember that the function is minus 2 divided by, okay, we found this one to be exactly x plus 4, but it was minus 3 as well. We have that y itself is 0. So in the place of f of x, we put 0 and we divide it by x plus 4 minus 3. And we transpose the 3, negative 3, making it positive, and we have x plus 4. We cross multiply, it becomes 3 by x, which is exactly 3x. 3 by 4, which is 12, equals minus 2. And which is 3x is minus 14, which means x is actually minus 14 over 3. Okay, now at this point, we have the following. So we have that x is exactly minus 14 over 3 and y is 0. Right, so this has given us the x-intercept of the hyperbola graph. It is exactly minus 14 and 0 there. The next thing in 4.3 is to sketch the graph of f, where we clearly label all intercepts with x's and the asymptotes. Okay, right, so we continue. Remember, this lesson is being recorded. The network can fail sometimes, and you can have glitches in the network. The sound might not always be perfect, but the recording will always be perfect. Okay, right. So I'm going to look at the function f of x we need to sketch. So it's minus 2 all divided by x plus 4, but minus 3. First things first, we need to realize that we have not calculated in these questions so far the y-intercept of f, the y-intercept of f. How do we calculate the y-intercept of f? We let x be equal to 0. When x equals 0, we have x equals 0, which is minus 2 divided by, we have 0 plus 4 minus 3, which is minus 2 over 4 minus 3, so which is minus 1 over 2, minus 3 there, right? So we actually take the LCD, which is 2. This is over 1. 2 divided by 2 is 1. By minus 1 is minus 1. Minus 2 divided by 1 is actually 2 by 3, 6. Okay, this gives us exactly a minus 7 over 2. Okay, so with minus 7 over 2, it actually communicates to us the fact that the x is that and the y is minus 7 over 2. Right, so that is exactly what we get. Okay, now this is it. We have the y-intercept, and then we can be able to sketch the graph. Right, sketching the graph is very, very easy. Let's get started. Right, with the sketching process, we must have the vertical axis, and we must also have the horizontal axis. Vertical, and then we must have the horizontal axis. Right, so the vertical axis is called the y, and the horizontal is always called x. We have two things here. We need to find the vertical asymptotes and the horizontal asymptote. Vertical asymptote and the horizontal asymptote. So this is minus 2 divided by x plus 4 minus 3. So now if we are to look at the vertical asymptote, right, with the vertical asymptote, we'll take x plus 4 equals 0, which means x is minus 4. But also, we have that for the horizontal asymptote, right, the horizontal asymptote, what do we have? We have that y is minus 3. Y is minus 3. So we have that x is minus 4. And then y is minus 3. Okay. And then y is minus 4. Okay. X is minus 4 and y is minus 3. All right. Now, what is this? We have found two intercepts with the x's. What are those intercepts? We have found the y-intercept, and the y-intercept is actually this one, at y equals minus 7 over 2, which is like minus 3.5. So minus 3.5 is somewhere there. Minus 3.5. Right, so if minus 3.5 is somewhere there, we can sketch. So, right, so when x is, at this point, x is minus 14 over 3. Right, minus 14 over 3 is like a minus 4 point something, so it's somewhere there, and the graph will take this pattern and shape. So we have this. So at this point is minus 14 over 3. So sketch the graph of f, showing clearly all the intercepts of the axis and the asymptotes. So the intercept with the axis is x equals minus 4 and the y equals minus 3. Okay, so we are done with the sketching process and we get our 4 marks there. The next thing we want to do is to do the next question. Once again, this lesson is being recorded, so everything I'm just moving. But yeah, these things will be available for you to watch again, and ensure that you take note of the things when you watch again. I'm also going to send you homework, but when you watch again, it's very important that you take down the notes. After having taken down the notes, you repeat the process by attempting the questions without looking at the answers. But you must study the answers first and make sure you understand the answers before you attempt the questions without looking at the answers to test your understanding. All right, now sketched below are the graphs of the two functions f and g. F and g, the f is the quadratic function and the g is the linear function 2x plus 4. Want to find the coordinates of a and b. A is here and b is there. What are those? These are the x-intercepts. So now, if you want to find things we call the x-intercepts, so you let y be 0. If y is 0, what do you get? Right, so you let y be 0 in the f function. So f of x is minus 2x squared plus 4x, right, plus 16. All right, so you continue with our discussion. Right, so which means when y is 0, we have 0 is minus 2x squared plus 4x plus 16. You divide it through by negative 2, which means x squared minus 2x minus 8. Dividing through by the negative 2 there. Okay, so what is all this? So then you group like this. Vectors of x squared are x and x, and then you have minus 4 eons. You have minus 4 and 2 and plus 2, which means x is 4 or x is minus 2. At this point, you have that x is minus 2 and 0, and you have that our x is 4 and 0. These are the coordinates of A and B. B is on the positive side, so B will have the coordinates 4 and 0. And x is on the negative side, rather A is on the negative side. It will therefore have those coordinates there. Next question, we need to determine the coordinates of C, the turning point of F. Right, here is C, the turning point. How do you find the coordinates of the turning point? We're looking at that one when the disconnection happened. So we have that at this point, we have our f of x. For you have x squared plus 4x plus 16. What is this? We're interested in finding so we note that at this point, these can be compared to ax squared plus bx plus c, at what point we have x equals minus b over double a. twice a, which is minus the b is 4 over twice a is minus 2. Minus 4 over minus 4, the result is 1. Okay, we got x equals 1. We just need to find the corresponding y value at the turning point. So we substitute into the function there. Wherever there is x, we put 1. We would have 1 squared plus 4, we put a 1, we have 16, which means f at 1 is minus 2 plus 20, which is 18. So at this point, our x is 1 and y is 18. Just note that. So we have this one is the point C, the vertex. So in other words, at this point, you have the following, that x is 1 and y is 18. Goodness me. Now, the next thing is we need to continue with solving this problem. And we shall write down the range of the function f. 5.3, the range. What is the range? The range of the function f is the set of the y values for which this is defined. What are the y values for which this is defined? So, which means y is less or equal to 18. So 18 or less, if you don't want to write it like that, you can actually say that y is an element. So it starts from 18 here and going down. So it goes down to negative infinity. So you'll say you have negative infinity to 18. So we always start from the smallest one. The smallest ones are at the bottom here. Minus infinity is further down, so you say minus infinity to 18, and 18 is a point on the quadratic function, on the parabola, and therefore your bracket must be a closed a square bracket there, square parenthesis. Okay, right. 5.4 is next. We want to deal with this one. Deal with the graph of the function h, which has a minimum value at 15. Minimum has a minimum value of 15 at x equals 2. Determine the values of p and q. Okay, let's do this one. Right, so to do this one is very, very straightforward. We are told that this one has a minimum value at the minimum value of 15 at x equal to 2, and then we just need to find the values of p and q. So in other words, we have the turning point. The turning point is having coordinates 1 and 18, and it is the point. Okay, so the examiner is suggesting a new turning point and is actually effectively saying h is this one has the minimum value of 15 at x equal to 2. So at x equal to, the minimum value is 15. The minimum value is 15 at x equals 2. Minimum value is 15 at x equals 2. So now, determine the values of p and q when it's x plus p, and then you have that q there. So in other words, you can see that at this point, you will have what? Because you have h, which is the same as f of x plus p plus q. So what is the meaning of these? Okay, what is the meaning of these? So at x equals 2, you have what? Right, so at x equals 2, at x equals 2, you have something. Okay, now you need to think very carefully here and do the correct substitution, because let's look at the y values. So now the function h is a transformation of g, but we have added q. So if you add something to 18, you say 18 plus something. plus Q. The result is 15. The result is 15. So what is Q? Q is going to be 15 minus 18, and Q is negative 3. So we have to find the values there. So Q is negative 3. Okay, now we have this. So we dealt with the Q. Now we are then saying the X value was what? The X value was 1, and then we added something to it. We added something to it, and the result became what? Became 2. What did we add to it? Right, so in other words, you had X equal to 1, and you added something to it, and the result became a 2. The result became a 2. What was essentially added there? So if you add P, it means that the X is going to be translated differently. So look at the translation. So it means that the X is going to be translated some units like that. It's going to be translated there in the opposite. And the meaning to that, therefore, or you can say, okay, you can do it in a couple of ways. You can do it in a couple of ways, and then say, what is this? Right. So you can say the way we did like here. The way we did it like here, where we got the values of P and Q, we did exactly the same thing. So we shall continue exactly with what we did. So let's look at what would happen here. So you would then say, at this point, you have X, and X was 1. You added a P to it, and the result became 2, right? And so what would the value of P be? Right, one way to look at these very carefully is to say, to get the value of P, you proceed as follows. If you have f of x plus P, and then now you want to get the value of P, how do you get the value of P? It really depends on what you add to the x to get the value of P. So, which means, therefore, you can say it's going to be 2 minus 1, which is exactly 1. So you get P is 1, right? Alternatively, so in other words, I started with P is 1. Alternatively, a very solid way to do that is to say, if you add P to that, you subtract the X value, and the result becomes 2. What did you subtract? So you would say you have minus P, and you have 2 minus 1, in which case you have 1, and then you have minus 1. Or you can look at it this way, and then say that you have that your P itself is actually a minus 1, right? So that is what you have, because you analyze what happened. The function, the X was what? The X was 1 at 1 and 18, but now it became 2. When it became 2, it meant that the translation was 1 unit. It was 1 unit. 1 unit to the right. 1 unit to the right. So how do you do it 1 unit to the right? You subtract. You subtract. Right. So that is what you have. So that is why the P is exactly like that. So the P is minus 1. Correct. So there are 2 answers there. Just note these transformations. You need to make sure you understand them. Now, the next question is 5.5. You need to determine the equation of G inverse, the inverse of G in the form that Right, the inverse of the equation of the inverse of g. What is g first and foremost? What kind of a function is g? G is a straight line, and we can easily find the equation of the inverse of a straight line. This is how we do it, so you need to learn it always and do it like this in the exam. So we first write G like this. And then we write the equation the examiner gave. So the examiner gave y equals, I'm taking it from here. They gave y equals 2x plus 4. And then next, below that, you write the equation of the inverse. Wherever, now the inverse swaps, reverses the roles of x and y. Wherever there is y, you put x. Whenever there is x, you put y, and you add 4. So that is how you deal with inverses. Just note that. So, okay, so we're done. So the inverse is the one below, but you can just make y the subject because now y looks like an implicit variable. Okay, so we want to make it the subject of the equation. So how do we do this? Right, so we can write 2y and we have x, we transpose the 4. You divide by the 2 and you have half x, you divide by 2 like this. Okay, we're good. We awesome, awesome, awesome. So now when we determine the equation in the form that, it's exactly in that form. So it's exactly in the form that. So the equation is exactly in the form half x minus 2. All right. Now, you look at the next one, 5.6. Right. For which values of x will this be the case? For which values of x will this be the case? Okay. For which values of x will this product be equal to 0? Right. So um, now you need to look at these. So you need to multiply them. So what is the inverse? So the inverse is the red one here. So the inverse has the equation minus half x minus 2. And what is g? G is 2x plus 4 is this one. That is the equation of g. And then if you equate these two to 0, what do these things give us? So you have half x minus 2 equals 0, or 2x plus 4 equals 0. Okay, so which means x is 4, or x is minus 2, which means x is 4 or x is minus 2. So this is it. X is 4, x is minus 2, so that's the answer. So in 5.7, we have this. P of x is equal to f of x plus k. Determine the value of values of k for which p and g will not intersect. Let's look at this one. Will not intersect. Right, 5.7. The marks are 5 of them. So let's see. Right, so 5.7 is a very interesting one. Look at the examiner playing little tricks. Right, so to do this one, you're going to say you have been given this, or you have been given p of x is f of x plus k. This was given by the examiner. Okay. You have been given this, for which p and g will not intersect. Right, so there's a couple of things you need to consider. What is the function p of x? What is the function p of x? What is the function p of x? So now we are really saying we have this. If this is the case, determine the values of k for which p and g. Okay, we know things first, that f is this one. F has the equation minus 2x squared plus 4x plus 16. What is our p of x? P of x. So p of x is f of x plus k. But we're then saying p and g will not intersect. So in other words, if p and g will not intersect, we'd be interested in looking at the part where these first are almost equal to each other. And then now, which means we are looking at we assume the g is equal to p of x. So we sort of assume that these functions intersect. And then we get to something called a contradiction. So we will therefore obtain 2x squared. Okay, 2x squared for the quadratic term. 4x minus 2x is 2x. So we're done with the x and the x terms and the quadratic terms. And then we have 16. 16 minus 4 is exactly 12. And then we add to it k, and this is equal to 0. This is actually b squared minus 4ac. And so, which means the b part is 2 squared minus 4a is minus 2. And this c is 12 plus k. Okay, if they do not intersect, the discriminant is less than 0. They don't intersect, so discriminant is negative. So which means if you square 2, you get 4 minus plus 8 into 12 plus k. So what is this? 100 plus 8k is less than 0. Which is, you move the 100 to the other side, it becomes minus 100, you divide by 8. And what we're getting here is that k is smaller than, we're getting that actually k is smaller than minus 12.5. Minus 12.5. Okay, so in other words, if they do not intersect, it would mean that the nature of roots, in other words, we shall be expecting something called the non-real roots. Okay, so and therefore the result is going to be minus 12.5. We continue. The next question is the exponential function. Question 6. There we're looking at 6.1, but 6.1.1. Right, so we have the function g. Write down the equation of g inverse in the form this. g of x is actually equal to 3 to the power x. Write down the equation of g inverse in the form that. Write down the equation of g inverse in that form. Okay, right. So we do the same like we did before. We write that the function g is having the equation y equals 3 to the power x. Then the function g inverse is actually the same as x equals 3 to the power y. And therefore, you can just make y the subject out of the last equation, from which you obtained y equals the log of x base 3. So we're using the log and we're making y the subject of the last equation. And this is what we get. So note that. The next thing is to look at 6.1.2. There's a point here they've given us, point P with coordinates 6 and 11. It lies on H, which is given by that equation. Now the graph of F is translated to form G. Write down the coordinates of the image of P on G. Right, so now we have been given the function H with the equation 3 to the power x minus 4 plus what? Plus 2. The point P lies on this equation. The graph of H is translated to form G. Write down the coordinates of the image of P on G. Okay, let's look at this one. So the kind of transformation, there's going to be a transformation here. A transformation as follows. This transformation is going to be, because you are making a comparison with, we are comparing the two functions h and g. G is just 3 to the power x. Now, what happens? What kind of a transformation can make it a point that we have that the graph of h is translated to form g? How do you translate h to g? So you translate by 4 units. 4 units left. 4 units left. In other words, you add 4, which is 4 units left. And then you have 2 units down, which means P will have coordinates 2 and what? Right. So in other words, we'll have the following. Okay, let me write it properly. You're going to have P with coordinates 6, 11. P primed is going to be 4 units left. So which means that if it's 4 units left, you're going to be exactly 6 minus 4. And then 2 units down, minus 2. The point P primed is going to have 2 and 9. 2 and 9. All right, 2 and 9. So that's what we have. Return the coordinates of the image of P. So we're calling the image of P, P primed. Right, the next thing is to focus on the next question. What is the next question? 6.2. Right, so in 6.2, we have this exponential function, and they're just asking us to find the values of p and q. Sketched is a graph of this exponential function, f of x equals 2 to the power x plus p plus q. T has the coordinates 3 and 16 is a point on f, and the asymptote of f is y equals minus 16. Right, so we want to find the coordinates, or rather the values of p and q. First things first, it's advisable to write down the equation of that has been given in the question. So it is exactly x plus p, but q is added here. So if this is minus 16, it actually means, therefore, our q is minus 16 as it appears. So which means that our q is minus 16. So here you would have that q is minus 16, which means our 16 is 2 to the power t. And then now we're going to do a substitution. We're going to do a substitution. We can take the point, the point t with coordinates 3, 16, for example. So y is, so this point, it's going to give us x and y. So y is 16 and x is 3 plus p plus q, which is minus 16. So, all right, so let's see. What is all this here? 16 plus 16 becomes 32, and we have 2 to the power 3 plus p. What is all this here? 16 is 32, excuse me, is 2 to the power 5, which is 2 to the power 3 plus 2. Three plus p equals 5, and then you have that p is equal to 2. Right, so what is this? We have found that p is 2, and we have found that q is minus 16, and these are the things we want. These are the things we want. P and q are these. Now we continue. We do the next question. We do finance, maths of finance, mathematics of finance, financial mathematics, question 7. Right, question 7 is about compound and simple interest calculations and the things we call ordinary annuities and annuity due calculations. Looking at 7.1. Right, an amount of 10,000 was invested for 4 years, earning interest of R% per annum compounded quarterly. At the end of 4 years, the total amount in the account was 13,000 plus. Determine the value of R. Determine the value of R. Determine the value of R. So you'd have to know the formula because it was an investment. It was an investment for 4 years, so we're going to use the formula for the investments, which means that it is a formula that has a plus, A equals P into 1 plus I to the power n. Okay? The total amount in the account was this at the end of the 4 years. So the future value became 13,080. When the present value, the amount that was invested, 10,000 was invested for 4 years. 10,000. Okay, R%. Minimum compounded quarterly. Right, we just need to determine the value of R. So this is going to be R divided by 4. R%, so you must you can write it in a couple of ways. The best way would be to say, if it's R%, you can just divide it by 4. Alternatively, you can do it in many, many ways. Many, many ways. All right. So um, you can do it in many ways, depending on what method, because the percentage means divided by 100. So you can divide by 100, and then you're going to get exactly the I there. Right. So if one wishes, you can divide by 100 and then divide by 4. Okay. And then you'll get the desired result. So in other words, you can say I, you divide by 100 and then divide by 4. So it becomes 400 like this. And then you raise it to the power. After 4 years, so you have the number of years 4 times 4 for the 4 quarters in a year. Right, so the next step would be to say 1380. You divide everything by 10,000, which equals 1 plus I divided by this. And it is exactly 4 by 4, which is 16. Want to solve for I, so you can take the 16th root both sides. 16th root both sides. So you can take the 16th root here. 16, which is 1380 divided by 10,000, which is the 16th root. 1 plus I over that, you raise it to 16. So which means that it's 1 plus I divided by that, which is actually equal to the 16th root of 1380. You have these at the bottom. What is this? What is this? So you can subtract everything here. You subtract u minus 1, etc. So you can have that I is 400 into 16, and we have the 1380 all divided by 10,000, and you subtract 1. And then now you need to get the answer to this. Right, so you need to get the answer to this, and you just need to do the calculation of these. What is the calculation of these? So we compute this one. To compute this one, we're gonna do the 16th root. The 16th root of 13,080. You divide it by 10,000. And then you minus 1. Okay, you multiply by what? By 400. Okay. And so what you're getting is therefore that it is 6,769, 6,76911, and it is exactly that 1%. It is exactly that 1%. So you get that it is exactly 6,7611%. Okay. So you note that. Now in 7.2, 7.2, a businesswoman deposited 9,000 into an account at the end of January 2014. She continued to make monthly deposits of Right, it was at the end, keyword, end of January 2014. He continued making monthly deposits of 9,000 at the end of each month up to the end of December 2018. So how many payments did she make altogether? End of January, February, like 12 in 1 year because it has 12 months. So we are looking at this one. All right. So calculate how much money was in the account immediately after 60 deposits have been made. After 60 deposits have been made. Right, so in 7.2.1, you have therefore that you have the following. There's something called a timeline. So you draw a timeline like this, and then you label the timeline, time 0, time 1, time 2, time 3, time 7, time 8, time 9, time 10. Right, so a businesswoman deposited into an account at the end of January 2014. So in other words, if this timeline represents the months, you have that there is the start of everything, and then at the end of January, 9,000 was deposited. You continue to make the monthly deposit of 9,000 at the end of each month. So now February started at the end of Feb, there was 9,000 deposited. And this continued 12. So you'd have 12 months. So this is 12, this is 11, this is 10. This is what? 9. Okay, timeline showing the months of the year. For the year, she continued to make the monthly deposit at the end of each month up to the end of December 2018. Okay, obviously this is much more than that because it's 2014 and then it is 2018. So just note that. So obviously it's a couple of years now. If you count from the year 2014 to 2018, you will realize a total of 5 years. 5 years, and that would mean that we're going to have more of this. You're going to have up to 60 months, 59, 58, 57. Okay, so the future value is x into 1 plus I to the power n minus 1 all divided by I, which is 9,000. The account end interest at a rate of 7.5% per annum compounded monthly. So if it is 7.5%, it's going to be 0.0. 7.5, you divide by what? It's monthly, divide by 12. But it's 5 years, counting from 2014 to 2018, but from the beginning of 2014. So it's 5 years. Right, so it's 5 years by 12, all divided by. 0,075 divided by 12. So which is exactly 652 74395. So which means therefore the future value is going to be this one. The future value is going to be that one. Six five two seven four three comma 95. 7.2.2. Okay, the businesswoman calculate how much money was in the account immediately after 60 deposits have been made. So we got that. The businesswoman left the amount calculated in 7.2.1 for a further 8 months in the account. The interest rate remained unchanged and no further repayments were made. The interest rate earned over the entire investment period, rather the interest earned over the entire investment period was that on 190,214 and 14 cents, determine the value of N. $60. Right, so at this point, we realize, therefore, that it was immediately 60 deposits were made. So if 60 deposits were made, you need to determine the value of N. So you therefore have to say 60 times 9,000, which is, because the payments were 9,000 each, which is 540. And then you have this 540. So this is the amount of money that was paid altogether. This is the amount of money that was paid altogether. Okay. So how much money was there in the account? 652,743.95. So 652 743.95. 1 plus is divided by 12. So right. So if you use a calculator, this is the same as 190. 190 and then 214, 14 plus 540. So in other words, this is what we're gonna get. Okay, 540,000. So this is the 652 that was left in the account. It grew for a given period. And when it grew for a given period, it actually reached maturity to this amount, but also added to that would be the total amount there of 540 of the payments. Because they're saying the businesswoman left the amount calculated in 7.2 for a further 9 months in the account. The interest rate remained unchanged and no further repayments were made, or no further payments were made. The total interest earned over the entire investment period was this. So it was exactly 190 and that. Okay. So the interest end was that one. So the interest is added to what? Is added to actually the payments that were made. So 730. Okay. um. So I need space here. 652. 95. 1 plus. You divide by 12. You raise it to the power n. 1186. Which is equal to 1.00625. So if you solve for n, it will become the log 625 base 1,1186. And therefore, what is this? Using a calculator, you realize that this is 18 months. 18 months. Determine the value of n. The value of n would exactly be 18 months. Okay, 18 months. See now how much time we've gone. Okay, let's practice a little bit of calculus. Question 8. Let's try the calculus questions. Right, determine f primed from first principles, given that that is the case. So you'd have that f of x, f primed is the limit, f, which is this. Limit. So which means that you have 3 into x plus h. F primed is the limit. So this is x squared plus 2xh plus h squared divided by h, which is 3x squared plus 6xh plus 3h squared minus 3x squared. Okay, so you have that this is the limit. Okay, h is a common factor. You can just pull out h and then you have 6x plus 3h. It is divided by h, and therefore h divides like this. And therefore, f primed plus 3h, which is 6x. It's x. Determine f prime of x from first principles if it is given that f x is 3x squared. 6.8.2. Okay, now we need to find just the derivatives f prime of x. This one was from first principles. So now we're going to look at 8.2 with a specific focus on 8.2.1. Plus 9 over x squared. Okay, let's find the derivative of the first derivative. So the first derivative is twice x minus 18x to the minus 3. Subtracting 1 from the exponent so that subtracting 1 from the exponent so that f of x is 2x minus 18 over x cubed. Normally we write our answers with positive exponents, so we just write it like that. Right, the next thing is to look at 8.2.2. G prime of x, when that is the case, so you have g of x, which is plus 3. Okay, we have x plus by x, which is x, minus the square root of x, plus 3 the square root of x, minus 3. So which is x minus 3 plus 2 the square root of x. So you need to now find the derivative g primed. 1 plus x. Okay, so the derivative here would be of x is 1, of minus 3 is 0. You bring down the 1/2 and then you subtract 1 from the exponent. And then what does this give us? That's the answer. So, but we can write it with positive what? Positive exponents, so that you have g of x. 1 plus 1 divided by x to the 1/2. So we found the first derivatives there, and we've answered question 8.2.2. Okay, so we continue. We continue. Okay, so we shall get these done. Okay, the next question is question 9. Okay, question 9 is about more calculus. And then we shall look at question 10. Okay, we shall try to be faster. So question 9. And question 9 now is based on the graph of the cubic function, this one. F of x equals 2x cubed plus 3x squared minus 12x. This graph is sketched below. And then what is all this? Right, determine the coordinates of A and B. So which means that now the A and B are the turning points. So you need to find the coordinates of the turning points. How do you find the coordinates of the turning points? Right, so in 9.1, we find the derivative of this. So first we have it. So you find the prime. Right, and then now this derivative must be equated to 0. Divide through by 6 and you get x squared plus x minus 2 equals 0. Because of x squared are x and x. And then now you have plus 2 minus 1. X equals 1. Substitute into the original equation, this one. So which means that you're going to have to get f evaluated at minus 2. So you'll get this one, but also you'll have to get f at 1, which is 2 into 1 cubed plus 3 into 1 minus 12 into that. So into 1. The answer is minus 7. So which means that A has coordinates x is minus 2 and x is minus 2 and y is 20. And then B will have coordinates x is 1 and y is minus 7. All right. So those would be the coordinates of A and B. Those would be the coordinates of A and B as required there. Those are the turning points. All right. Now the next one is 9.2. Which value of x will this f be concave up? First, we write f, 2x cubed. Find the first derivative. 6x squared plus 6x minus 12. Okay, so now this first, if it's concave up, then the second derivative must be greater than 0, which means that plus 6 is bigger than 0. So we continue. Okay. So you get that the answer is going to be 12x now is minus 6. Okay, let's write properly. Which means that you have 12x 9.3, determine the equation of the tangent to f at c equals 2 and 4. Which values of x? So it will be concave up for the values of x bigger than what? Strictly bigger than minus 1/2. So now let's look at the next question. Okay, let's look at the next question. Nine point three. Determine the equation of the tangent to f at c with coordinates 2 and 4. Now, the equation of the tangent to f, all right, at c with these. So now you need to find the derivative of the function f. For the function f of x, the first derivative, what is it? 6x squared plus 6x minus 12. We evaluate these at 2. You square it because x is 2 at c. So you evaluate at 2 and then the answer is what? The answer is 24. What is the equation of the tangent now? Okay, we have found the m primed, which is the gradient. So it is the slope. It is the slope. Right, it is the slope. Equation of the tangent. Which means at C with coordinates 2, 4, y minus y 1. Y equals minus 48 plus 4. Minus 44. To 24x minus 44. We found the equation of the tangent to f at the point C. And the equation of the tangent is y equals 24x minus 44. Question 10. Right, the graph of f of x equals x cubed plus bx squared plus cx plus d has 2 turning points. It's a cubic function. It has 2 turning points as usual. The following information about f is also given that f at 2 is equal to 0. Okay, so that gives us an x-intercept. The x-axis is tangent to the graph of f at minus 1. F primed is 0. F primed at that is bigger than 0, 10.1. Without calculating the equation of f, use this information to draw a sketch graph of f. Indicating the coordinates of the intercepts and the turning points. Okay, don't need to find the equation, let's just draw a sketch graph of this. So we have this. This goes there. Minus 1, x-axis is a tangent to graph f at minus 1. But f at 2 is equal to 0. So there's a 2 here. F primed at x equal to 1 is 0. This is the y-axis and this is the x-axis. It's a couple of things like f primed at 1/2 is positive, meaning that at 1/2 the function is actually increasing. So we have answered the question. Okay. Now we continue to look at 10.2. O is the center of the semicircle passing through A, B, C, and D, and the radius of the semicircle is x minus x squared units for x lying between 0 and 1. The triangle AOB is right angled at the center O. Show that the area of the shaded part is given by these. Show that the area of the shaded part is given by these. Right, so a couple of things now are very important here. So to get the area of the shaded part, we need to get the area of the segment. Area of the segment. Right, so the O is the center of the semicircle passing through the radius. The radius of the semicircle is that one. Okay, the triangle AOP is right angled at O. Need to show that the area of the shaded part is given by that. Okay, straightforward. You need to look at the fact that if you have this here, area of the segment. Area of big circle. Area of big circle. Area of big circle. Right, so at this point, right. So now, it then follows that you have 1/4, the area of the big circle is pi radius squared, and the radius is x minus that. So this is 1/4. What is the area of the big circle? Is pi radius squared, and the radius is x minus x squared, pi radius squared. And then now we just need to get the area of the triangle AOB. So you can draw a baby triangle like this. Area of triangle ABO. Counted. Area of the triangle ABO is the area of the triangle is the area of a triangle is actually, you can look at it in many ways. This one opposite, you can call it A, opposite, you can call it B. So it's like half A, if this one is A and this is B. So it's half AB sine O. Okay, so which means that it is half x minus x squared. A is x minus x squared, that is the radius. So x minus x squared is the radius, x minus x squared, x minus x squared is the radius, and then you multiply by the sine of the included angle, which is 90 degrees. So this is 1/2 into x minus x squared, squared like this, which is the area of triangle. Now the area of the shaded region. Area of the shaded region. What is the area of the shaded region? Area of the shaded region is the area which is 1/4, we saw x minus x squared squared. Then you just subtract the area of the triangle, which is half x minus x squared squared like this. Common factor manipulation and simplification. Right, so if you simplify this, it simplifies to pi minus 2, putting out the common factor of the quadratic, over 4. The common factor is x minus x squared all squared. Right, so this one is pi minus 2 over 4. And then you square everything, which is x squared minus 2x cubed plus x to the 4th power. So you need to show that the area of the shaded part is given by this, and there it is. This is the area of the shaded part is given by exactly that for 5 marks. For 5 marks. We find the area of the triangle. We found the area of the segment. And then we set the area of the segment minus the area of the triangle, and then we got everything there. Now the next thing is 10.2.2. Determine the value of x for which the shaded area will be a maximum. Determine the value of x for which the shaded area will be a maximum. So in other words, for the shaded area to become a maximum, if you say the area is pi minus 2 from the previous question, x squared minus 2x cubed plus x to the 4th power. Okay, so now if we want to get the maximum, in calculus we find the derivative and we make it equal to 0, we equate it to 0. So I'm going to find the derivative, so it's pi minus that over 4. And then this pi is a number, it's a constant, we don't worry about it. We just only find the derivative of the x terms. X squared, the derivative is 2x. Derivative of 2x cubed is minus 6x squared. The derivative of x to the 4th power is 4x cubed, which therefore means that 4x cubed minus 6x squared plus 2x equals 0. Common factor. So you have now the common factor, you can pull out just a 2x. And then that gives us a 2x squared minus 3x plus 1 is equal to 0. Which means 2x minus 1, x minus 1. X is not 0. X is 1. X is not 1. So determine the value of x for which the shaded region will be maximum. So it will be maximum when x is exactly 1/2. Well, the reasons that we remove these, because you can see that the radius is x minus x squared. The radius has the length x minus x squared. So if you put 0 there, you're going to have a radius of 0. That's why this one is out. But also this one is going to be 1 minus 1 squared. And then 1 minus 1 is 0. So it doesn't work. So the only radius that works is, well, the only x value that works is x equal to 1/2. Right, the time is exactly what? Right, the time is exactly 12:20. And we started at approximately 10:38. We started at approximately that time. Let's see what time it was. Okay, I wrote the time somewhere here. We started at about 10:48 because of the glitch, and then I thought we were going to stop at 11:48, but we just by the grace continued up to 12:21 right now. I think that we can call it a very good afternoon. So you have a chance to rewatch this. When you pass through this again, you write down the questions, you write down the answers, and have your notes, because your notes are very important to help you learn, because you learn from your notes. The videos must be converted to notes so that they can help learning. And then we take it from there. Okay, and then we need to meet also during the week. We shall discuss. We can discuss in the evenings whenever it is possible. It can be late hours, evening, late at night, 8 o'clock p.m., etc. 9, can do 8 to 8 to 9, 9 to 10, etc. at night. We need to catch up. It's end of year now. We need to go all out. There's no time left. Okay, but thanks for the morning and have a good morning. I'll send these in about 3 minutes to 1 hour, the recording of the video. Okay.
Okay.
Okay. I'm sorry that you've been watching. Sometimes I try to just talk, and I know there's always a chance of falling asleep and getting bored, you know. There are those discussions where we shall be interacting and we shall talk, but yeah, I just thought it's ideal. I just give much information. All right.
Okay.
So thanks a lot. We'll talk then. You let me know about the weekday. We can use evening time or something so that we have that extra hour. But it is my wish that we move to 2 hours, our 2-hour discussions during the weekends. So you advise me where you can start so that from this coming weekend, we need to do 2 hours to try to cut to recap on lost time, to regain lost time, etc. That kind of thing. All right. But thanks a lot and have a good morning or a good day.
Okay.
All right then. Goodbye. Goodbye, Mpo.
Bye.
Goodbye.